All right. So we're going to do, now you can start filming, right? Filming. Okay. So we're going to do set 2.3. We're going to do 4 through 36, 4K, 4K plus 1. That's multiples of 4 and the one after. Everybody understand that part, right? Okay. So the ones I want to do are with you so that you can see how they're done. I want to do, oh wait, 2.3. Did I say 2.2? I said 2.3? Okay. Yeah, we're going to do 2.3. I want to do number 12 with you. I want to do 20 with you. I want to do 29 with you. 25 with you. 33 and 36. Did somebody write those down that I just said?
I got 29, 25, 30, 39, 6.
Okay.
I got before that.
And so 12.
20.
I want to do 20 and 8. Okay. All right, let's start with 8. Now, some of these we've already kind of semi-done. It's just a quick little review, okay? So read me number 8. And we'll just go around the class, say your name, and then tell me the problem number. So what's your name? Courtney? Is that right?
Yeah.
And you got to be kind of loud because the air conditioner's on high, so I can't hardly hear. So Courtney, we're going to do number 8. What does number 8 say? Parenthesis what?
Minus 12 minus n parentheses squared.
Okay, so this goes back to Pascal's triangle, right? And I'm going to do this the real fast way. Now remember, what this really means is what? What does it mean? It means you have two quantities, negative 12 minus n times negative 12 minus n. One of the most missed questions on the ACT is this question. The reason it's missed is so many kids want to put 144 plus n squared. What did they do? How'd they get 144 plus n squared? They squared this term and they squared what? That term. And they think they're done. But what are they missing? They're missing the middle inside-outside terms combined together. You with me on that? But if you'll do it using Pascal's triangle, first term squared, first term times second term times 2, last term squared, that's how you do it. So again, let me say that again. First term squared, first term times second term times 2, or doubled, however you want to think of that, and last term squared. That's what we're going to do. First term squared. So over here, we'll start on this side answering questions. What's your name?
Sydney.
Sydney, what's negative 12 squared?
144.
How come it's positive?
Because
Negative times a negative is a positive. Okay. Then I got first term times second term times 2. What's your name?
cadence.
Cadence. What's that going to be?
Sorry, what?
First term times second term double.
Wouldn't it just be negative and 144?
So negative times a negative is a
Positive.
positive. 12 times n is 12n. Doubled. What's 12 doubled?
144.
24n. Everybody see that? That's the hard part of this. First term times second term. Negative 12 times negative n. Then I double it. I always use that too as just kind of a reminder to double it. But negative times a negative is a positive. 12n doubled is 24n. Okay? Then I take the last term squared. That's going to be what, Cadence? That's easy. Plus what?
Plus 1.
Plus n what?
N squared.
N squared, yeah. That's the easy part, okay? That's it. That's your answer, okay? First term squared. First term times second term doubled. Last term squared. You'll get the same thing if you distribute the negative 12 and you distribute the negative n. It just takes longer, right? This little shortcut comes from that Pascal's triangle we showed you on Friday, okay? Where you do first term squared, first term times second term times 2 or double, and then last term squared. So that's all I'm doing, so I'm doing it faster. It's faster than that. Okay, next one. Somebody read me the next question. Go ahead. Oh, what's your name?
I'm
MJ, read me the next question that I was going to go over. What one was it, 12?
Yeah.
Okay, what is 12? Is it a picture?
Yeah.
Okay, so 12 is going to have a picture. It's kind of a square looking thing, and I think they break it up into like this. Is that right? Is that how it looks?
Yeah.
Okay. What's this length right here?
So X.
7. What's this length across here? Also 7. And then these right here are what? X. Is this X?
Yeah.
Okay. And this is X and this is X, right? Okay, and it wants the area of this. Now area is just length times what? Width. So add your like terms here. What do you get? 2x plus what? 7. And then this is also what? So this is just 2x plus 7 what? Squared. Yeah. Because you're just going to times this side to this side. Well, that's just squaring. Now it's just like this problem. We're going to square it out. Okay, so let's go fast here. Guy in the back, what's your name?
Me?
Yeah.
Caden.
Caden, then you're going to be next. What's your name?
Riddick.
Riddick. So Caden, then Riddick. Caden, square that out.
So it's going to be 8x squared.
Nope.
No, 4x squared.
4x squared. There you go. First term times second term, double. Go ahead, Riddick. First term times second term, double.
28x.
Very good. He did 14, then he did 28, doubling it. X. Very good. Okay. Last term squared, go ahead and do that, Riddick, because it's pretty easy. 7 squared is
49.
49. There you go, you're done. That's all there is to it. So pretty quick, okay? Once you have a quantity squared, first term times second term doubled, last term squared really fast. Okay? My other class, I make them write it out this way and times everything out, but it's a pain in the butt.
Okay.
The Pascal's triangle says, hey, I can do it this way. It's a quantity squared. First term squared, first term times second term doubled, last term squared. So, okay, next one. What's your name? Aspen, go ahead.
Parentheses 1/2 minus 1/2 plus.
What are these called? We talked about it last time. One has they're exactly the same. One's negative, one's positive.
Positive.
They're called conjugates. Conjugates, what will happen with the outside and inside terms? Yeah, they add to 0. So like MJ said, so I really don't have to do that, do I? And I'm like, no, you don't have to do that. That's what makes these awesome. Because you only have to times the first terms and the last terms. That's it. So I'm going to multiply these first terms. This is tricky because most kids miss this. What's your name?
Sabrina.
What?
Sabrina.
Sabrina. What do I get when I take a half times a half?
4th.
A fourth. Very good. Most kids miss that and they think it's like a whole. They'll put 1. But it's a fourth. Okay, so I multiply the first terms. And then notice if I distribute, I'm going to get a half C and then a negative half C. Those are going to add to 0. But I get in the habit of not even doing that once I see their conjugates. Okay. So what's your name?
One.
Yeah.
Simeon.
Simeon. Multiply those two. What do I get? Positive times a negative is a
Is it 0?
positive times, not adding.
Oh yeah. So it's negative c squared.
Very good. Are those perfect squares? Yes, you'll always get a difference of perfect squares. 1/4 is a perfect square because the square root of that is a half. Are you with me? Square root of c squared is obviously c. So you're going to get a difference of perfect squares every time you multiply conjugates. That's the key. Okay? Next one. Who's next? You're next. What's your name? Alex. What's the next one? Next problem that I said I was going to do. What is it, you guys?
25.
25. Read me 25, Alex. Loud. 16 times 24. And so we don't want to use a calculator. I mean, everybody can use a calculator and find that. But we're going to use this special rule that we have up here, thinking, what is the midpoint between those? What's the midpoint between 16 and 24? 20. So to get 16, we would do 20 minus what? 4. And to get 24, we would do 20 plus 4. Everybody agree with that? That's all I'm doing. I'm saying, what's the midpoint? That's the key question you ask yourself. What's the midpoint between these two? And then use that midpoint, either plus or minus, to get these values. Midpoint minus 4, 16. Midpoint plus 4, 24. Now the reason we're using the midpoint is this equidistance part is going to give us a conjugate. And that makes life easy. So we're going to do this part. Now we're still working our way around. So who's after Simeon? What's your name?
Jacqueline.
Jacqueline. What's 20 times 20?
400.
400. And then I can ignore the inside and outside. Remember MJ said we don't have to worry about that. What's your name? Faith?
Sadie.
Sadie. Sadie, we're just going to multiply these two. What do we get?
Minus 14.
Close. Minus what? 16. And we just add them. 400 minus 16 is? 384. That's the answer. If you want to check it, you can do it on your calculator and say, hey, is really 16 times 24 384? It is. But I can do it pretty quick doing that. Okay? And again, we're just trying to make it faster, quicker. Okay? Next one. Who's next? Right here. Caleb, right? Caleb, what's the next one? What are we doing? What's the next one, you guys?
29.
29. Read me 29, Caleb. Oh, 3.5 squared? Oh, 30.5 squared, right? Is that right? Okay, so how can I write this? Well, this one, if it's in a quantity squared, needs to look like this in a quantity squared. You with me? So I just want to go back to the whole number and split it in half. So isn't 30.5 the same as 30 plus a half squared? That's all I want to do. Okay? Then it makes it easy again because I'm just going to take first term squared. What's the first term squared? What's 30 squared? I think we're on Sadie still, aren't we? No, we just did Sadie, right? So Caleb, sorry, we're going around this way. So Caleb, what's 30 squared? 900. First term times second term doubled. So 30 times a half is 30 halves, but then I double it, it just becomes what? What's your name? Yeah, and memory. Memory, what's this one? So 30 times a half doubled is, multiplying. 30 times a half doubled is, think about it, 30 times a half times 2. What happens? Those go away. It's easy. It's what? 30. That's what I mean. It actually makes things easier. So now I have plus 30, and then I take the last term squared. What's the last term squared? Plus what? 1/4. Add those together. 930 and 1/4. That's my answer. Again, you can actually do it on your calculator. Do 30.5 squared and see if that's the answer. Should be. Kind of cool though, because you can make it easy without using the calculator. Okay. Next one. Who are we on? Memory? Are we on you? Okay. Go ahead. I don't know what number is it, you guys?
33.
What is it?
33.
33. Memory. Tell me what 33 says.
A contractor extends the house on 2 sides. And then it says 50 feet.
So is it a picture like this?
Yeah.
And then he adds this?
Yeah.
Okay. So we have a contractor. This length right here is what?
50.
50 here?
Yeah.
What's this length? Also 50? Okay. And this is X?
Yeah.
And he wants to add that to it, right? And what does it ask for?
The area of the house after the renovation is represented by x plus 50 squared.
Yep. Find this product. Okay, so all they're saying is, what is the area of the whole entire renovation? So the area is length times width, x plus 50 squared. Right? And it says find this product. Again, I'm going to use that special product rule. First term squared, first term times second term times 2, last term squared. Where did we end up at? Memory? Is that where we ended up? What's your name? Say it again.
Kenzie.
Kenzie. Kenzie, what am I going to get when I square that whole thing out? You do the whole thing this time.
X squared.
X squared, then what? First term times second term double. 100x. Very good. Plus 100x, then what? Last term squared. What's 50 squared? What's 5 squared?
25.
Pi squared is 25, and then times 100 because that's 10 squared. So it's going to be 2,500. Okay, that's 50 squared. Do you see how I did that? 10 squared is 100, 5 squared is 25, so it's 2,500. Okay, that's it. I'm done. That's the part A. What does part B say?
Use the polynomial in part A to find the area when x equals 15.
So if we're expanding by 15 feet, this house, so if that's 15, what will the whole area be? Well, I just put 15 in here. What's 15 squared? What's 15 times 15? What's 10 squared? What's 10 squared? 100, and then 5 squared is? Oh, that isn't right. Shoot, I wish it would have been. 15 times 15 is 225. I don't know how else to do it. I'm trying to make it easy. Okay? 15 times 15 is 225. Okay? So that's all I'm doing is putting in 15. 15 times 100 is 1,500, right? Plus 2,500. This was 15 squared. That's 225. And so I'm just putting 15 in everywhere there. Add all those together, what do I get? Well, 2,500 and 1,500 is 4,025. Or 225, sorry. 4,225 square feet. That's the answer on that. Okay, what number was that? 33. Flip it over. Last one that we're doing, I think, is what?
36.
Okay, I've never done this one before, so we'll see how it goes. Let's see, I think we're on you, right? But I'm just going to read this so that I can see. Your iris controls the amount of light that enters your eye by changing the size of your pupil. So normally if your whole eye is 6 millimeters, the distance to your pupil is x, okay? Write a polynomial that represents the area of your pupil, just the pupil. Write your answer in terms of pi. So let's think about that. We have an eye. Okay, so we have an eye, and the radius is what? 6 millimeters, right? And then we have this pupil, and this pupil changes, by the way. If it's really bright and light, what will happen to your eye, by the way? Yeah, it gets really small. That pupil gets really small. If there's hardly any light, like if you're playing night golf by moonlight or something, has anybody ever done that besides me? Probably not. Okay, so if you're playing night golf by moonlight, your eye actually, the black part of your eye is huge. Because it's letting in a lot of what? A lot of light, see? So that's what that's doing. So this x value changes, okay? So how do I do the area? What's the area of a circle, first of all? What is it?
Radius squared times pi.
Yeah, pi r squared. It's easy to remember because it's cake. That's funny.
What?
The area of a circle is easy to remember because it's cake. What's cake? Pi r squared. Pi r squared. Pi r squared. Okay,
Oh,
never
I got it.
mind. All right.
I got it.
So it's cake. What's the area of a circle? It's cake. Pi r squared. All right. So we got 6 pi squared, right? But we got to do what? Because it only wants the area of that inside. What do we got to subtract from this? Subtract what? X. So I want to rewrite this. So this is the area of the whole eye. Whole eye. If I want just the, I think what they call this part? Pupil? The pupil, right? So if they want the pupil, okay, then I got to put what? 6 pi minus what? X squared. Correct? Okay. And I think that's the answer to A. Is it? Or what does it say? Write a polynomial that represents this area of your pupil. Write your area in terms of pi. Okay. So in other words, it wants us to square that out. Can I square that out? Yep, same way I've been doing it. So where are we at? I forgot where we were at. I think we're on you, right? Alex? What's 6 pi squared?
36 pi squared.
Good. Leave the pi the way it is. So we're going to write 36 pi squared. First term times second term, yes.
Isn't the area of a circle radius squared multiplied?
Radius squared times pi r squared. Oh, you're right. My bad. I'm going to put that pi out there to the side. Good call. My bad. That's just 6 pi. Sorry, the pi is outside. Radius squared times pi. Sorry, my bad. It changes it a little bit, but not much. It's just the pi that's going to change, right? Good call, Alex. Okay, so I'm going to put this as 6 squared is 36. And then first term times second term doubled. Go ahead, Alex. Minus what? First term times second term doubled.
Minus 12x.
Minus 12x. Last term squared. Plus x squared. A lot of kids mess that sign up there. It's a negative times a negative. It'll be a what? Positive. Okay, so that's it. Times what? Times pi. This is the pupil area. That's the answer to what? A. Okay, what does B say? The width x of your iris decreases from 4 millimeters to 2 millimeters when you enter a dark room. How many times greater is the area of your pupil after entering the room than before you enter the room? So let's do after and before. So that's easy because all I got to do is after I enter the room, I'm going to put A of what? After I enter the room, what's the value of x? I enter the dark room, what's x going to be? 2, right? Yep. So I'm going to put A of 2. That stands for after I entered the dark room, I'm going to only have an x value of 2, which means my pupil is bigger, right? So let's do that. Put in a 2 there. What are you going to get? 2 squared is? So 36 minus 24 plus 4. I was going to do negative 20. That equals 16 what? Pi is the size of the pupil after you entered the room. Before you entered the room, what's it going to be? So we're going to put B for before. Before you entered the room, what was the value of x? 4. So let's put in the 4. 4 times 12 is? What's 4 times 12? 48. 4 squared is 16. 16 minus 46 is negative 30 plus 6. This is 6 pi. Pupil. Okay. All right. And what did it say? What did it want us to know? What the question asked. By the way, this is always tricky on story problems. Don't just think that, hey, I've done all my math, I'm done. Think, what does the question ask? What does the question ask? How many times bigger is this than this? Well, it's more than 2, right? Because double this would be what? 12. Is it 3 times bigger? What's 3 times that?
18.
18. No, it's 2.5, right? And check that. Do 2.5 times 6. And see if that's right. Somebody do that on your calculator. 2.5 times 6. Is that right? It's not right?
You're 36 minus 46. Just let me at 48.
Yeah.
Oh, man. Huh?
46 would be a 40.
Because it's
Oh.
4 times 12.
My bad. Sorry, 48. Good catch. Wait, we're going to change this. Okay, so what's that going to be then? That's 32. This is 4 pi, right? Oh, that makes this way easier. Yeah, it would have been 2.5 if it was 6, but it's not. It's 4. Now I'm going to do what? 4 times 4 would be what? 16, so it's 4 times bigger. That's my answer. Okay, you can stop.